Welcome. Today, we dive into the beating heart of Hadoop's data ecosystem, a Hadoop Distributed File System HDFS. Imagine a system so resilient it can withstand hardware failures, so scalable it manages exabytes of data across thousands of servers, and so economical it runs on affordable commodity hardware. This isn't science fiction, it's HDFS, the foundational bedrock enabling massive scale data storage and analytics. At its core, HDFS is a distributed, fault-tolerant file system engineered for the era of big data. Born from the pioneering concepts of Google's file system, it's purpose-built to handle petabytes to exabytes of information across clusters of ordinary servers. Unlike traditional file systems, HDFS thrives where data is vast and hardware is imperfect. It's the core storage engine of Apache Hadoop, optimized not for real-time transactions, but for high-throughput batch processing where massive datasets are analyzed in sweeping, sequential operations. Why was HDFS designed this way? 4 pillars define its mission. First, fault tolerance. Hardware fails, disks die, nodes crash. HDFS anticipates this, automatically rerouting tasks and replicating data. Second, scalability. Need more space? Just add servers. HDFS scales horizontally to thousands of nodes seamlessly. Third, high throughput. It prioritizes streaming reads/writes of huge files, perfect for batch analytics. Fourth, cost effectiveness. It leverages inexpensive commodity hardware, making colossal storage accessible. Picture an orchestra. The NameNode is the conductor, the master. It holds the entire file system's blueprint in memory, file paths, block locations, permissions. Its critical metadata lives in FS, image the file system snapshot, and edit log real-time changes. The DataNodes are the musician slaves storing actual data blocks. They constantly send heartbeats to the NameNode, signaling their health. And the secondary NameNode? It's the conductor's assistant, performing vital checkpoints to merge FS image and edit log, preventing the NameNode from being overwhelmed. In modern Hadoop 2x+ high availability, HA ensures no single point of failure, dual NameNodes active and standby stand ready. How does HDFS tame colossal files? By splitting them into blocks, default 128 MB or 256 MB chunks. Each block is replicated across multiple data nodes, typically 3 times. But replication isn't random, it's strategic. The first replica lies local to the writer. The second goes to a different rack for failure isolation. The third lands on another node within that second rack, balancing fault tolerance and cross-rack traffic. This is rack awareness, a genius dance minimizing network congestion while maximizing resilience. Writing data. The client splits the file, asks the NameNode for DataNode targets, then initiates a pipeline write. Data flows from client write arrow D none write arrow D into a write arrow D N3 in a chain stream, efficient and parallelized. Reading. The client fetches block locations from the NameNode, then reads directly from the nearest DataNode, enabling massive parallelism. This direct data streaming avoids bottlenecking the NameNode, ensuring blistering throughput for batch jobs. Failure is inevitable. HDFS treats it as routine. If a DataNode dies missing heartbeat, the NameNode instantly triggers block re-replication from surviving copies. Data corruption. Checksums are verified on every read/write. Corrupt blocks are discarded and regenerated. For the critical NameNode, HA high availability pairs an active node with a standby, using shared storage like Quorum Journal Manager QJM. If the active fails, the standby takes over in seconds, no metadata lost. HDFS is a powerhouse, but it's not universal. Its strengths shine, managing petabytes, thriving on cheap hardware, offering bulletproof fault tolerance, and excelling at batch workloads. Yet know its limits. It's not for low-latency queries like databases. It supports only single writers per file. Small files bloat NameNode memory, and the NameNode's metadata must fit in RAM memory-bound scalability. Choose HDFS where scale and throughput trump speed and granularity. Observe the elegance. The client interacts with 2 layers. Metadata ops flow to the NameNode, the brain managing the file system tree. Data ops stream directly to DataNodes, the muscle storing block A's replicas across physically dispersed nodes. See replica 1 on D none, replica 2 on D N2 different rack, replica 3 on D N3 same rack as D N2. This is distributed storage in action, coordinated, resilient, and massively parallel. Where does HDFS dominate? batch processing, log analytics, ethyl, data warehousing, Hive/HBase, ML training on giant datasets, and long-term archival storage. So remember, HDFS is Hadoop scalable, fault-tolerant backbone. It thrives on large files and batch jobs. Replication plus rack awareness equals unshakable resilience. And at its core, the NameNode metadata maestro in DataNode's data workhorses. Master these concepts, and you master the foundation of big data storage.